So let's look at the major blood vessels that we have: the artery, vein, and capillary. The artery takes blood away from the heart. Vein returns blood back to the heart. Capillary connects the artery and the vein. So artery takes blood away. Capillary links the two, while the vein returns blood to the heart. Okay? So the pressure in the artery is high because the heart pumps. So when the heart pumps blood, it applies pressure to the blood and the blood flows through the artery. As the blood from the artery goes to the capillary, the pressure drops. As the blood from the capillary goes to the vein, the pressure drops more before it comes back to the heart. So at the artery, we say it has high pressure. The blood there is at high pressure. Capillary, the blood is at low pressure. And vein, the blood is at low pressure. Okay? So what happens about the valve? The blood passing through the artery being at high pressure due to the pumping effect of the heart. There is no need for valve in the artery because when the heart contracts, the pressure alone is enough to push blood away and along the artery. Okay? So the artery does not need valve. When the blood is coming back from the vein to the heart, the blood is moving sluggishly. Therefore, vein needs valve. Valve helps blood to flow in one direction to allow it going back while coming up to the heart, while flowing to the heart. The capillary does not need valve because at the capillary, that is where exchange of material, oxygen, and whatever takes place between the blood and the body tissue. So here, the artery, we say that valve is absent. At the capillary, no need for valve. Valve is also absent here. Here, say that valve is present. Okay? Valve is present. So, if the blood in the artery is at high pressure and you puncture the artery, how do you think that the blood will flow out? When you puncture the artery, the blood will come out forcefully. We say that the blood spurts out when you puncture the artery. But in the capillary, where you have low pressure, when you puncture it, the blood oozes out, comes out slowly. So also at the vein, moving at low pressure, when you puncture your vein, the blood comes out slowly. So here, we say that the blood spurts out. Here, the blood oozes out. And here, the blood oozes out as well. Okay? Then, how do you think that the thickness of the artery will be? The artery that carries blood away. Remember that the heart pumps blood. Okay? So the pressure in the blood has to be contained. And therefore, the artery has to be thick to contain the pressure so that the blood vessel will not what? Rupture due to the pressure in the blood. So the artery is thicker than the vein. The vein, the blood there is moving sluggishly. So there is no fear of the blood vessel or the vein rupturing. So the blood vessel there is thinner. In capillary is just one cell layer. Okay, so it's very thin. It's a tiny blood vessel. Okay, so it's to enable or to enhance exchange of material between the blood and the body tissue. That is why the capillary is tiny. So here we say that the blood vessel, the artery is thick. Here it is thin, and here it is also thin. Okay. Then what about elasticity? When the heart contracts and blood comes out, the artery has to be elastic so that when the blood pumps out, it can enlarge to contain the pumping effect of the blood. Okay. As it expands, it can also contract so that the blood can flow. Okay. So we say that it actually is elastic. Due to the low blood pressure in the vein has no need of contracting and expanding. So it's less elastic. And the pressure there is low. The capillary, the pressure is low, so there is no need of expansion and contraction because of low pressure in it. So at that point, we say that here is more elastic, here less elastic, the wall is less elastic, here is less elastic. That is the muscular wall of the blood vessels. Okay. Then what about the opening? If I check this, if I take this and this, and if this is my artery and this is my vein, I can have this and this. You can see that here the artery is more thicker. Okay, this one is less thicker. You can see that this is more thicker and this is less thicker, which we just saw now. 16, and this is thick. Then coming to the lumen, this opening here is known as the lumen. Here is the lumen. Here is the lumen. The lumen of the artery is narrow. Okay. It said narrow lumen. The lumen is narrow. Here, the lumen is wider. We have the wider lumen. In the vein, but in the capillary is tiny, very tiny blood vessels. So therefore, the lumen is tiny. Okay? You put tiny lumen. Okay? So when we come to the color of the blood, the artery in systemic circulation, okay, pumps blood to various parts of the body and back to the heart. And the blood is highly saturated. The blood is highly saturated. Okay? So, saturated with oxygen. Okay? This is highly saturated. Okay? With what? Oxygen. So as the blood that contains enough oxygen moves, gets to the capillary, there is exchange of gases, material, nutrients, and waste between the blood and the body tissues. Okay? So at that point in time, the blood becomes less saturated. And as it moves to the vein, it keeps on being less saturated. So, but the blood at the side of the artery going to the capillary is more saturated with oxygen, while the blood coming out of the artery of the capillary through the vein is less saturated with oxygen. Okay, so here we say that saturated at arterial end and less saturated at venue end. Venue end, at the venue end. So at the vein, the blood is highly unsaturated. Okay? We say that it is highly unsaturated. Highly unsaturated. So if blood is saturated with oxygen, automatically the color of the blood should be red, bright red. Okay? Because hemoglobin, when combines with oxygen, makes the blood to be what? Bright red. So the blood at the artery is bright red. Okay? So at the capillary as well, the blood at the arterial end is bright red, while the blood at the venous end is dark red. Why is blood dark red? Because it is less saturated with oxygen. The blood at the vein returning back to the heart is dark red because of what? Highly unsaturated with oxygen. So here we say that the blood is bright red at the artery. Here it is bright red okay. So here we have it. So it's bright red at arterial end and the dark red at venue end. Venue end at venue end. While here it is dark red at the vein. Okay, so when you check the blood pressure at the systemic circulation, blood pressure in the artery is within the range of 120 over 80 in normal healthy person, but the blood pressure at the vein is within that range of 2 to 6 millimeter mercury. So that tells you that the pressure drops at the vein. Okay. So let's see the position of the ball. Let's change here. If I should use this to represent the artery, small branches like this, branches of the artery, the branches of the artery is called arteriole. So all this branch, this division is what is called the arteriole. When the arteriole divides, the arteriole can divide, and where they divide, okay, so this is the artery giving rise to the arteriole. Where they divide, they form this, the capillary. We have the capillary here. So division of arterioles give rise to the capillary. We have the capillary here. The capillary, and capillary, okay? So when the capillary is joined, they give rise to venue, okay? And when the venue, have the venue here, you can see each venue here. When the venue join, they give rise to the vein. So venue is the tiny branch, okay, that form the vein. Arterioles are tiny branches of the artery. So division of the arteriole will give the capillary. And capillaries can also connect in a manner to enhance exchange of material, okay? In a manner to enhance exchange of material, okay? So it is at the capillary that exchange of material occurs. Here we have the body tissues or body cells, and the tissues surrounding the capillary, okay, like this. So when the blood is pumped from the heart through the artery, you can see the artery, okay, and the blood is highly saturated with oxygen, the blood moves and gets to this. Let me just use one capillary, enters here, okay. As the blood is flowing, we call this side, we refer to this ending as the arterial end. The arterial end of the capillary, So this side is called the venue end, of the capillary, okay? The venue end of the capillary, okay? So as the blood is coming here, containing nutrients, oxygen, gases, and every other thing, there will be exchange of material